Welcome to the first lab. The first lab is the circuit lab, in which you will be asked to recreate these 20 different circuits. This sheet shows you schematic diagrams of the circuits, where you have 3 light bulbs, A, B, and C, and you're either going to have them in parallel, like this first case, or in series, or in some combination, like number 5 here, where you have A and B in parallel to each other, and then they join up and are in series with C. Okay. Or where B and C are in parallel or in series, but parallel to A. And this is what we're showing here is that the current comes from a transformer. It delivers 6 volts. You throw that switch to allow the 6 volts, and the current will flow down here through these wires across the bulbs, light them up as the current returns back to the source. If it doesn't return back to the source, it won't light up. Okay, and so if I throw this switch to the outside and this switch to the outside, I've got current coming down here, flowing through this switch, through this bulb, and then through this switch back to the source again. Notice that these 6 switches here have 3 poles to them. The center pole has a wire that's connected to the bulb, and it goes on and connects to the center pole here. The switch will swing from the outside poles. So if you wanted to connect to the source here, you would throw this to the outside, and this one here would have to be thrown to the outside so that the current will return. So the current comes down here, goes through this bar to this wire, to the bulb, comes to this middle post, and then goes out again. If you wanted to connect this pole to this pole, you would just throw this switch here. And this pole to this pole, you would throw this switch. Okay. Well, these are the assignments. And let's just take a look at this first one, A, B, and C in parallel. And so I'm going to throw these all to the outside. In this case, the bulb, the current comes down here, is split, and goes through these 3 switches, through these bulbs, and then it comes back together here. So you can follow the current with your fingers. Of course, it splits again, comes back here, and then rejoins. In this case, the bulbs are relatively bright. Turn the lights up here, and you can see that they are relatively bright. Each one is receiving 6 volts from the source. When they're in parallel, they receive the full voltage. Okay. If they're in series, then the sum of the voltage drop across each of these elements have to add up to the total voltage, which is 6 volts. So in the case of having 3 in series, they'd each receive 1/3 of 6 volts, or 2 volts each. And consequently, they would appear to be dim. All right. These here are bright, and you record them as bright. These here would be dim, and you record them as dim. Okay. Now, if you're making these circuits and you're following your current paths, and you happen to travel across a wire twice, well, that'll be a short, any sort of parallelism or a loop like that, where current comes back on itself, or you use a wire twice, is a short, and consequently, one of the lights will go dim, will be shorted out. And so that would be an impossible one, and you would have to mark it as impossible. Of these 20, there will be as many as perhaps 4 that are impossible to do, and you'll just mark them on your report as impossible. You'll be working with one of 6 different boards, and so you have to indicate on your report which board you're using. All right. And like I said, some boards will have at least 4 impossible diagrams that can't be made. Others will have perhaps 3, I think. Well, in this first one, we have an answer sheet that you can fill in. This is for your benefit. You are going to record your brightness and dimness of the bulbs in the lab report. But for here, you can take and indicate the diagrams by filling this in. This is the case where you have A, B, and C in parallel. And I'm showing by filling in, these are the 3 poles, and you connected the middle pole with the outside pole, middle pole with the outside pole in each of these cases. And so the current comes out of the transformer, goes through the bulb and out in each of these poles. And now if you happen to create another one where diagram, another circuit where you use an interior line, you can draw that interior line with a colored pencil. Each of these interior lines are colored yellow, blue, or red. And in this case here, I have A and B in series. Yeah, hold this up to you. A and B in series. That is to say, I'm going to come down here from A, go through A, but I'm not going to go out. I need to connect to B. So I have to throw this to the inside. Well, how can I get to B? Well, I can get to B by throwing this switch here. That allows me to go down this brown wire through this switch to this brown wire. Okay. And then throw this switch, and I go down to this brown wire, which is hardwired to this yellow wire. And I can throw this to the inside so that I'm connected now to the bulb B. And I come out here, and I throw this to the outside, and A and B are now in series. Okay. So I've indicated that I've used these switches here, these switches, and these switches to make A and B in series. And I've shown that this is thrown to the outside, and this is thrown to the outside for B. Okay, these 2 side switches here have been thrown, so I show them connected. And then I try to, with a yellow pencil, which you may not see very well, but I added a dotted line here to show you I used the yellow wire to connect to this pole. So this is A and B in series. And let me turn this off. And you can see as compared to the other situation for A, B, and C in parallel, these are dimmer. You'll find in each of these cases the currents necessarily seem to have to pass from left to right through the bulbs. And so the whole trick is once you get to this side, you have to come back to this side in order to go through another bulb that's in series. So that's where you'll be using these interior switches here and the interior lines, wires that are on the board. Okay, I realize that this, of course, is an AC power supply, and we're really talking about AC. You really have AC current here, but you're just to view this as if it's DC. That is to say, it's starting here, goes through the circuit, and comes back. All right, and that's all there is to it. You'll see the write up, and just complete that table, and then there'll be a question about another lab, a part of this lab that has light bulbs, regular household light bulbs, that we're going to connect up in parallel in series. And I'm going to show you that in another video. And you'll have questions in the lab to answer about that. Well, good luck. I'll talk to you all soon.